This is a question from Irodov, Irodov, from electrostatics portion. This is a question number 3.16 of Irodov. The question says, a sphere of radius r carries a surface charge of density sigma equal to a dot r vector, where a vector is a constant vector. A vector is a constant vector and r vector is the radius vector. So let me take this as the constant vector. This is a constant vector and this is one r vector. This is the radius vector. Okay, so this gives us ar cos of theta. So sigma যেটো surface density আছে হেতু কি দিছে, this gives ar cos theta. Okay, this gives ar cos theta. So now, so this theta is the angle between a vector and r vector. This is the angle theta. Now if we look in the sphere, then আমি কি দেখা পাম যে first half in the sense this first part and this is second part. I think this first part. In the first part, the value of theta, okay, the value of cos theta is equal to positive for first half. That is right part. Okay, and value of cos theta is negative for left part of the sphere. Okay, now from this we can say that sigma equal to positive for right part and is equal to negative for left part. Okay, for left part. Now we can have positive charges over this part of this sphere. এফালে আমরা positive charge দিব পাৰো, right? Because according to the given condition or situation, this part of this sphere will have positive surface charge density and left part of it will have the negative surface charge density. So we can draw this like this. Okay, so now from the symmetry we can say that both part will have the electric field of same magnitude. You can say it from the symmetry, same magnitude at the center. This from symmetry. Okay, center and in the same direction and in the same direction. So electric field at O, that is at the center, is equal to E1. E1 means the electric field because of the right part of the sphere, and E2 because of the left part of the sphere. And this will be the total electric field. This will be the total or net electric field at center O. Okay, so now for doing the electric field, for calculating the electric field at the center, what we will do, we will first calculate it for the first part of this sphere, then we will multiply it with 2 because both will have the same direction, because at the center for the first half electric field will be along this direction, and for the second half also, because it is negatively charged part of the sphere, so both will have the same direction. This is U1 and this is E2, so we need to add it vectorially. Okay, now first we will go for the first part or right part of the sphere. Okay, so now we will do it for the first part. We will do it one by one. If I can do this here, I can do this for this part also, because it will be symmetric. So let me do this here. Okay, this is our center, this is the A vector. Now let me draw one elemental ring here, okay, on the surface. Now let me draw one elemental ring here. This is our elemental ring, this one. এইটো আমাৰ elemental ring এটা draw কৰিলো of radius suppose r, okay, radius r, and this was our r, and this is our theta. Then this portion will become r. Okay, this portion will become r d theta. Okay, r d theta. Now let this be r. Okay, then this portion will be r d theta, and this is your elemental ring. Okay, so this is your elemental ring. Now for this elemental ring, what is the area of the elemental ring? Area of the elemental ring. This is a small ring, let it be dA, and this dA equal to, we know that length into width. So this is 2 pi r is the length of this particular elemental ring, into dr means that is width is r d theta. So we can write here is r d theta. Now what is the r here? From this triangle, from this triangle, from this and this, O A, suppose it is B, from OAB you see r equal to r sin theta, is it? So we can write dA as 2 pi r sin theta into r d theta. Okay, so for this we can write 2 pi r square sin theta d theta, correct? Okay, so now what will be dq for this particular ring? So dq is the charge on the elemental ring, will be and this will be equal to sigma into dA, is it? And for this part sigma was positive, and it is ar cos theta, okay, into dA. dA is this one from equation number 1, you can say. So we can put it here, 2 pi r square sin theta into d theta. Okay, so if you do this, you will get twice pi a r cube cos theta sin theta d theta. Okay, cos theta sin theta d theta. This is equation number 2. Now we have the charge on the elemental ring and charge on elemental area. Now if we have the charge on this elemental ring, we can use the electric field due to a uniformly charged ring, okay, at its axial point, because this center is the axial point or point on the axis of this particular elemental ring. Now we know that for any ring, okay, for any ring of charge q, the electric field at any axial point is given by, if its radius is r, is given by q by 4 pi epsilon naught. If this radial point is x, then qx by 4 pi epsilon naught r square plus x square to the power 3 by 2. Now where r is the radius of this ring and x is the distance of the field point, electric field point from the center of the ring. Now for our case, the x equal to what? For our case, x equal to AO and r equal to r sin theta. So electric field due to this small elemental ring can be written as dq AO by 4 pi epsilon naught r square plus AO square to the power 3 by 2. Okay, so now we had value of dq is from previous calculation, twice pi a r cube cos theta sin theta d theta. Okay, and value of AO is r sin theta divided by 4 pi epsilon naught. Value of r is r sin theta, so it is r square sin square theta, plus value of AO is r square cos square theta to the power 3 by 2. Okay, so if you do this calculation, you will get is equal to twice pi a r cube, here one another r, so r to the power 4. Okay, r to the power 4, because this r cube and this r it will be r to the power 4. Then sine theta, cos theta 1 here, no, this should be, you see, this should be r cos theta, right? R cos theta. Okay, let me correct this, because AO, this was the value of AO, right? This r cos theta. Okay, r cos theta. Why? Because you see here you can see this portion AO OA, this is R, so this should be R cos theta. Okay, so this is the value of AO, so this should be R cos theta. Okay, so sin theta cos square theta d theta divided by 4 pi epsilon naught, this r square sin square theta and r square cos square theta, r square take common, cos square theta sin square 1, so it will come out to be r cube. Okay, so from this r cube and this r to the power 4, it will be r. Okay, then again this 2 pi 4 pi is 2. Okay, now we'll be left with AR sin theta cos square theta d theta divided by 2 epsilon naught. Okay, so we'll be left with this one. So from this now, for net electric field at center O is given by, because this was our DE. Okay, this is the electric field only because of, and this was the electric field only because of the elemental ring, and there are several rings like that. Okay, here if you see, there are several elemental ring here. The rings start from this point and theta at 0 degree to pi by 2. Okay, limit of this first element will be here, first ring will be here, then at the last we will get a ring here which will have a theta at theta is equal to 90 degree, right? And the elemental ring what we have taken, আমি যেটো লৈছো হেতু কিহত থাকিব, that is at theta is equal to theta, but our limit is from 0 to pi by 2. Okay, so we need to integrate this from 0 to pi by 2. The E is equal to integration DE, and this will be equal to integration AR sin theta cos square theta d theta by 2 epsilon naught from 0 to pi by 2, right? So if we do this, we will get AR constant, AR by 2 epsilon naught, we can bring it out, 0 to pi by 2 sin theta cos square theta d theta. So now you need to do this integration part, it is very easy. Moving ahead, AR by 2 epsilon naught, we can break this into sin theta into 1 minus cos square theta is 1 minus sin square theta, you can write d theta again, so AR by 2 epsilon naught integration 0 to pi by 2 sine theta d theta minus integration 0 to pi by 2 sine cube theta d theta. Is it? Okay. So this equal to AR by 2 epsilon naught. If we do this, we will get integration of sine theta minus cos theta 0 to pi by 2 minus, again we will break this using the formula of sine 3 theta. So it will be 3 sine theta minus sine 3 theta divided by 4 into d theta. Okay, so if we do this, AR by 2 epsilon naught, it will be cos pi by 2 is 0, 0 minus of cos 0 degree. Okay, this will be what? Minus of cos pi by 2 minus of minus cos 0 degree. Okay, so minus 1 by 4 integration 0 to pi by 2 3 sine theta d theta minus integration sine 3 theta d theta, again from 0 to pi by 2. Okay, it is AR by 2 epsilon naught, it is 1 minus 1 by 4 integration of this 3 sine theta d theta will be minus 3 cos theta by 2. Okay, minus of minus cos 3 theta divided by 3 0 to pi by 2. Okay, okay, then it is AR by 2 epsilon naught 1 minus, if you put the limit you will get 1 by 4. This is, first one is 3 cos pi by 2 is 90, so first one will be 3 cos theta cos 0 1 minus minus plus, so 3 minus this will be 1 by 3. Okay, so this will give you AR by 2 epsilon naught 1 minus 3 by 4 plus 1 by 12. This will be equal to AR by 2 epsilon naught. If you do this, you will get 1 by 3. So you are getting at as 1 AR by 6 epsilon naught. And our direction was, and this was the total electric field of the first part, first half. Okay, this was the electric field because of the first half. So we have got the electric field to be AR by 6 epsilon naught. Okay, now you see, this is the electric field at the center along this direction, right? Along the, if you take this as x, this is minus x, so we can write it as along the negative x axis, right? Here by 6 epsilon naught. And there was another half part. So there was another half part with negative surface charge density, but by symmetry the electric field will be along the same direction. You see, this was E1, this was E2, so both will have the same magnitude, so total electric field E will be equal to E1 plus E2, and both will have the same magnitude, so it will be net electric field will be 2 into AR by 6 epsilon naught minus IK. Okay, so 2 3 is 6, so it is AR by 3 epsilon naught minus IK. So this is our answer. Okay, this is our required answer. Thank you.